This will be a plastic collision. We'll say two football players are tackling each other. So let's say we've got football player here. And this football player is running towards the other one with speed VA1. And then we've got another football player. Let's say VA1, let's see, VA1 equals 3 meters per second. And mass of player A equals 135 kilograms. So he's almost 300 pounds. He's gigantic. Then let's say we've got another football player. Maybe this one is a little bit smaller, but still kind of big. And he's running with the ball to the left, and he's running with speed VB1. And his mass of B, is 120 kilograms. So he's about 250 pounds. So if we're given these pre-collision speeds and the masses, we need to find the post-collision velocities. So that would be VA2 and VB2. Now, one more thing that we need to be given that we weren't is coefficient of restitution. And we'll say this is a plastic collision and E equals 0. So this means that the two players are going to stick together like people normally do in a tackle. They're going to stick together. So that tells us that if they stick together, then the post-collision speeds are going to be the same. VA2 and VB2 are going to be the same. So let's set this problem up. If E equals 0, then we actually don't even need to use the E equation because we will only have one unknown, and that will be the post-collision speed. So we'll use the conservation of momentum equation from here, and we'll say MA VA1 plus MB VB1 equals, the objects stick, so we combine the masses, MA plus MB V2, because they share that same speed. So now we just need to plug in the numbers, and we'll say that, let's see. Oh, we need to, let's say VB1 equals 4 meters per second. We needed to have that. And we'll assign a coordinate frame, and we'll say that X goes here along the line of impact and Y goes up. So we're going to put positive velocity in the positive X direction. So VA will be +3, and then VB, because he's running to the left, will be -4 when we plug into here. So let's put these numbers in now. So we'll have 135 times VA1, which is 3, plus the 120 for MB, and then VB1 is going to be -4. So we don't even know which way these players are going to go once they stick together, because B is a little bit smaller, but he's running faster. A is a little bit bigger, but he's running slower. So we know that they stick together, but we don't know which way they go. So if our final velocity comes out to be positive, they end up going to the right and player A dominated. If they end up is with a negative speed, then that means they're going to the left and player B is the one that dominated there. So we'll continue putting everything in. So here we'll have the 135 plus 120 here, and then finally times V2. We get -0.29 equals V2. and this is meters per second. So negative 0.29 in the I hat if we're getting velocity here.